Butane is the chemical name of C4H10. So that's in Mother Eats Peanut Butter. That is the fourth in the alkane family of hydrocarbons. Okay, and so the structure or the structural formula of butane, so that's the structure, or just called the Lewis structure. That's the two-dimensional, how the atoms and how they're bonded. So this is a carbon, a carbon, a carbon, a carbon, 4 carbons, and then adding all those hydrogens. Okay, so this takes some time. And because it takes some time, there's a shortcut, which is called the condensed structural formula. The condensed structural formula shows just what's bonded at each carbon atom. Okay, so what is bonded at each carbon atom? The group at each carbon atom, the first grouping here is a CH3. So this is going to be written as CH3. Don't need to draw the bonds out. The next grouping here is a CH2. So just need to write that, a carbon with 2 hydrogens. Then this is another CH2. And then this on the end here is a CH3. So this is called the condensed structural formula. It just shows the carbons and what is bonded to each carbon, and that again is shorter than the structural formula. Well, even shorter than that is the line angle drawing. So this has carbons are indicated by just being where 2 lines intersect. Okay, so where 2 lines join, or at the end of a line. And then hydrogens are implied, and they fill in the rest. And the hydrogens have to fill in the rest, meaning that so that each carbon can have 4 bonds. Okay, so any bonds that are not shown are going to hydrogens. So the line angle drawing of this molecule, butane, is going to have 1, 2, 3, 4 carbons. So this would be this carbon, this CH3 is here. Okay, so this is a carbon that has 3 bonds implied because there's one going to this next carbon, and this is the CH2. Okay, so this is a carbon with 2 bonds coming out of it, and then there must be 2 other hydrogens there that aren't needing to be shown in the line angle drawing. This, where 2 lines join here, is this carbon. Okay, so this carbon has 2 lines coming out of it. It's bonded to these 2 carbons, and there must be 2 hydrogens on there. Okay, and then this last is this carbon. So this last carbon has 1 bond coming out of it, and therefore there must be 3 other hydrogens on there. So the line angle drawing is just a zigzag line, but that zigzag line has a lot of meaning to it. This represents the structure of butane. It's the quickest to draw, and that's why it's the most commonly used, because as molecules have a lot more carbons and a lot more hydrogens, line angle drawings are used for organic molecules that have a lot of carbon and hydrogens, and it's a way to quickly draw the molecule structure. So the zigzag line you see here is not a zigzag line. It represents a lot of carbons with the associated number of hydrogen atoms. So each end of a line and everywhere where 2 lines join, which is a vertex, is going to represent a carbon. So this is the end of a line, and that's a carbon. This is the end of a line, and that's a carbon. And this is the end of a line, and that's a carbon. Okay. The vertexes, that's where 2 lines meet. So where 2 lines join, that's a vertex or an angle. Okay, so this is an angle where 2 lines join. There's a carbon there. This is an angle where 2 lines join. And this is a vertex, which is a 3-way angle where 3 lines join. Okay, so these are all carbons in there. And to have the appropriate number of hydrogen atoms, that is so that each carbon has 4 bonds. Okay, so there needs to be 4 lines coming out of a carbon. Each of these carbons at the end has 1 bond coming out of it, and then therefore there are 3 more hydrogens. So this carbon at the end, this carbon at the end, and this carbon at the end, these are all CH3. So there's a carbon with 3 hydrogens and a carbon with 3 hydrogens. Okay, the carbons that are in the middle, so any of these carbons that are in the middle, these ones that are orange, these have 2 lines coming out of, this actually has 3 lines coming out of it, so there's only 1 more needed for the hydrogen. So there's 1, 2, 3 lines bonded to other carbons, so there's only 1 more needed for the hydrogen. So this is CH, okay? These others, the other 2 here, you have, this is a carbon with 2 bonds already to other carbons. This is a carbon already with 2 bonds to other carbons. So this is a CH2 each time. So this is a CH2, and this is a CH2. This is a way to quickly show the structure, and another way that's used is the condensed structural formula. So the condensed structural formula shows what's bonded to each carbon. So the summary here is that this is going to be a CH3, okay, and then the next is a CH. So this CH group is next that it's bonded to, but this CH is bonded to this branch, which is a CH3. So this is a branch off the main chain. The main chain being the zigzag line going left and right. Okay, so this is a branch coming off that main chain, and it is in parentheses. Okay. So then this continues on with CH2, CH2, CH3. So keep writing that in the condensed structural formula, CH2, CH2, and CH3. So this would be the condensed structural formula of this line angle drawing. And this is the name of that compound. It's called isohexane because this is a 6 carbon. So it's C6, and it has 14 hydrogens. You can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's hexane, but it's called an isomer of hexane because hexane is all single bonds. It's the alkane with all single bonds, hexane, but this is an isomer of hexane because it has this branch. So we'll look at these isomer structures as well. This is an official name for isohexane, which is 2-methylpentane, and we'll also look at organic compound naming. This is this line angle drawing below. This looks like a pentagon. It's not a pentagon. So just like a zigzag line isn't a zigzag line, this is also not a pentagon. What this is where 2 lines meet means this is a carbon. So where 2 lines meet represents a carbon. So each of these vertexes or vertices is a carbon. And when each of these carbons has 2 lines coming out of it, that means that there have to be 2 more bonds going to hydrogens that are not shown on the line angle drawing. So this is on each of these vertices is a CH2 group because each carbon has 2 bonds coming out of it, so the other 2 are to hydrogens. So each of these is a CH2 group. This actually would also be the same as its condensed structural formula. And the chemical name for this compound is starting from pentane. So pentane would be 5 carbons and all single bonds. So this has 5 carbons and all single bonds, but is a ring structure. So we're also going to be looking at ring structures because rings become very important in the structures of medicines and drugs. So this is a ring structure, and so it's called cyclo, the ring version of pentane.
This line angle drawing is the isomer of hexane. So hexane normally would just be a zigzag line with 6 carbons and 14 hydrogens. This has 5 carbons, 1, 2, 3, 4, 5, and then the 6th carbon is a branch off the main chain. So the definition of an isomer is when there's a different structure of the same chemical formula. So this 6 carbons and 14 hydrogens, whether being a straight chain or the branched chain. These are two isomers of butane. So they have the same chemical formula, which is the same carbons, 4 carbons, and 10 hydrogens. So 1, 2, 3, 4, and then here's 3, 5, 7, and 10 hydrogens. So the same is true about the isobutane. It's C4H10. So these are the condensed structural formulas showing what's bonded to each carbon. So this is butane, which is the straight chain, CH3, CH2, CH2, CH3, and it's shown as this zigzag line, the ball and stick model, and you can see that the shape, the space-filling model, which is the closest representation to how it is in nature, is basically just linear. So isobutane, even though it has the same chemical formula, which is C4H10, a lot of things are different. So the condensed structural formula is different. There's a branch off the main chain, which is 1, 2, 3 carbons, and then the 4th carbon is a branch off that center carbon. That's indicated on the condensed structural formula as this is a CH3 group. This is the 4th carbon that's in a parentheses. This is a total of 4 carbons, but the structure is pretty different when you have a branch off that main chain. So you can see that branch, this is the center carbon with another carbon coming off of it, and the shape is kind of a thick triangle, which is pretty different than this thick line. We'll see how important the three-dimensional shapes of molecules are in the function of these molecules in health and in medicine. So this three-dimensional shape is pretty different from this three-dimensional shape, and so these have different functions. And even though they have the same chemical formula and they have the same atoms, ultimately the shape is what drives the function of molecules.